Hello everybody, welcome to CAMS Engineering. This is part 3 for how to make a powerful subassembly from Autodesk Subassembly Composer. In previous two videos we had seen how to make lane layers. Different conditions for our shoulder slope by using if function. Different conditions for fill daylight. Shoulder layers and fill condition, high fill widening. I think you don't like it because I have got only 6 subscribers. It's my new YouTube channel, and after finishing this interesting subassembly in next video we will see different types of civil engineering softwares like EaglePoint.Ms project, inroads. And also we will see how to use AI technology, video editing. Today I will continue from last point. Let's start. First, change the condition from fill to cut, open our target parameter, and change our EG preview value from negative to positive. Okay, now it is changed to cut condition. Open our cut flowchart. Before we go through our steps, let's first decide our input parameters for cut condition. First, we will define enumeration for different types of ditches. Click on View at left top side. Click on Define Enumeration, Create Enumeration Group. Here we want to create different types of ditches. I will give enum group name ditch type without space. Next, we will create enumeration item. We will make 5 different types of ditches, but we will enumerate only 3. We will make the other 2 simply by changing parameters. Our first ditch type is reinforced concrete U ditch. I call it our CUD. Our second ditch type is masonry U ditch. I call it MUD. Our third ditch type is trapezoidal ditch. I call it TRAD. Next, we will insert our ditch input parameters. First, its type is ditch type. We already define it now. Its name is type ditch without space. I will call its display name type of ditches. You can give any name. Next, DT, its default name is ditch thickness. It is double. I will give 0.1. Again, you can give any number because we can change it in Civil 3D. Next, DW, its default name is ditch width. It is double. I will give 0.5. Again, you can give any number because we can change it in Civil 3D. Next, DD. Its default name is ditch depth. It is double. I will give 0.8. Again, you can give any number because we can change it in Civil 3D. Next, DS. Its default name is ditch slope. It is not double, it is slope. I will give 1 to 1 for default value. Again, you can give any number because we can change it in Civil 3D. Next, DI. Its default name is ditch insertion point. It is double. I will give 0.3. Again, you can give any number because we can change it in Civil 3D. It's enough for now. We will start making our ditches. Insert a switch. Its expression is type ditch.value without space. It is case sensitive. Please spell correctly or copy-paste using Ctrl-C and V. Next, we will insert 3 flowcharts for our 3 types of ditches. Give the names for each flowchart, but it's also case sensitive. Please spell correctly. Now we will start making our first ditch, that is reinforced concrete U-ditch. Open the chart. And changed the input parameter to our CUD. Now insert our first point. Its type is delta x delta y. It starts from point 11. Its delta x is dt. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 22, that is our last point. Its delta y is negative dd because it's below the point. Draw a link. Insert next point. Its type is again delta x delta y. It starts from point 23, that is our last point. Its delta x is dw our ditch width. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 24, that is our last point. Its delta y is positive dd our ditch depth. Draw a link. Insert next point. Its type is delta x delta y ... It starts from point 25, that is our last point. Its delta x is positive dt our ditch thickness. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 26, that is our last point. Its delta y is negative dd minus dt, assuming that our wall thickness is equal to our bottom thickness. If I is different, you can insert another input parameter. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 27, that is our last point. Its delta x is negative dt minus dw minus dt. That is twice our ditch thickness. Draw a link. Insert a link. It starts from point 11. It ends on point 28. Finally, we will insert a shape and define it. As we had discussed before, we will give all the codes in short method after finishing this assembly. We have finished our reinforced concrete U-ditch. Now let's go to our masonry U-ditch. Change the input parameter from reinforced concrete U-ditch to masonry U-ditch, and open the masonry U-ditch flowchart. Insert our first point. Its type is delta x delta y. It starts from point 11. Its delta x is dt. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 29, that is our last point. Its delta y is negative dd because it's below the point. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 30, that is our last point. Its delta x is dw. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 31, that is our last point. Its delta y is positive dd. Draw a link. Insert next point. Its type is delta x delta y. It starts from point 32, that is our last point. Its delta x is positive dt. Draw a link. Insert next point. In this case, its type is not delta x delta y, but it is slope delta y. It starts from point 33, that is our last point. Its slope is negative ds, that is our ditch slope. Its delta y is negative dd minus dt. Draw a link. Come to the opposite side. Insert a point. It is slope delta y. Its slope is negative ditch slope. It starts from point 11. Its delta y is negative ditch slope minus ditch thickness. We have to reverse our slope, otherwise it will be like this. Insert a final link. It starts from point 34. It ends on point 35. But in most cases, our ditch thickness for masonry ditch is 0.3. By the way, you give any number in Civil 3D, and the ditch slope is 0.4 to 1. Finally, insert a shape. We have finished our masonry U-ditch. Before we go through the steps how to make trapezoidal ditch, let's see a highlight. You know it, but you have to remember. The first thing is offset it by 0.2 meters or our ditch thickness. As you have seen at this point, if we connect this point with this one, our ditch slope will be changed. Therefore, we have to find the exact intersection point. Yes, this will be our exact point, not the first one. We will see it how to get this point in Subassembly Composer. Let's see the other. Our top thickness for our trapezoidal ditch is this horizontal line, not the thickness of the ditch. This value is nothing but use Pythagoras' theorem. A square plus b square is equal to c square. As we all know it, one side is the thickness, and the other side is thickness divided by ditch slope. Let's go to our interesting composer. First, change Masonry U ditch to trapezoidal ditch in. Input-output parameter and open our trapezoidal ditch flowchart. Insert our first point. It is our ditch insertion point, that is where our ditch starts. If you don't need it, you can ignore this step. Its type is slope delta y. Its slope is negative ditch slope. Its delta y is negative ditch insertion point. It starts from point 11. You can draw a link or not. Now we will define our trapezoidal top thickness. As per our previous discussion, it is simple but mathematical calculation. It is double. I call it TT, that means trapezoidal top. You can give any name. Its default is math.square root of dt square plus dt divided by ds square. Please spell correctly or see on screen. Now insert a point. It is delta x delta y. It starts from point 36. Its delta x's are new TT, and draw a link. Insert next point. It is slope delta y. It starts from point 37. Its slope is negative ditch slope. Its delta y is negative ditch depth, and draw a link. Insert next point. It is delta x delta y. It starts from point 38. Its delta x is ditch width, and draw a link. Insert next point. It is slope delta y. It starts from point 39. Its slope is positive ditch slope. Its delta y is positive ditch depth, and draw a link. Insert next point. It is delta x delta y. It starts from point 40. Its delta x's are new tt, and draw a link. Here we have to remember our previous discussion. Let's find our exact point. First, insert a false point. It is delta x delta y. It starts from point 39. Its delta y is negative ditch thickness. Please don't draw a link here. It is false point. Now insert intersection point to find our exact point. Its intersection type is two-point slope. The first point is point 41. Its slope is negative ditch slope. The second point is point 42. Its slope is 0, that is horizontal. And our first slope is reverse slope. After getting our exact point, insert a link. It starts from point 41 and ends on point 43. Okay, again, we will find intersection point between 2 points. Insert intersection point. Its intersection type is 2-point slope. The first point is point 43. Its slope is 0, that is horizontal. The second point is point 36. Its slope is negative ditch slope. And our first slope is reverse slope. After this, insert a link. It starts from point 43 and ends on point 44. Again, insert a link. It starts from point 36 and ends on point 44. Finally, our shape. Therefore, we have finished 3 types of ditches, and we will see the other 2 ditches simply by changing the parameters. Mostly our trapezoidal ditch thickness is 0.2. We will see how to get V-shaped ditch and earthen ditch by simply changing the parameters after finishing our shoulder layers. Now draw a link which uses for our shoulder. Insert a link. It starts from point 11 and ends on point 44. Change the link name from link 55 to any number greater than or equal to 55. I will change it to link 60. We will give this link number to Masonry U-ditch. Change to Masonry U-ditch. Change the name of link 44 to link 60. Sorry, open Masonry U-ditch flowchart. Now you can canch. Again, change to reinforced concrete U-ditch from input-output parameter. Open our reinforced concrete U-ditch flowchart. Change the name of link 37 to link 60. Now we will connect all flowcharts to one. Insert a flowchart. Connect these flowcharts to our new flowchart. Open a flowchart. We will do everything in this flowchart is used for all the three cases. Sorry to say this, all the steps for making our shoulder layers is exactly similar with the fill case, so you can see how to make from part to video. For now, I will speed up the video. Okay, everybody, we have finished our shoulder. Let's check if it works for others. Change to Masonry U ditch. Yes, it works. As you have seen it, all shoulder layers are visible here. Again, change to trapezoidal ditch. Yes, it works. Now let's change this trapezoidal U-shaped ditch to earthen ditch. Simply change ditch thickness to 0. It will automatically change to earthen ditch. Again, if you want to change it to V-shaped ditch, you simply change ditch width to 0. If you don't want insertion point, change insertion point default value to approximately 0. In next video, I will try to finish this interesting and powerful subassembly. Please subscribe, like, comment, and share. Thank you for listening.